Since you've chosen to click on this video, then you must want to learn about logarithmic functions.
Thank you for choosing this video. We hope that this information will help broaden your knowledge about logarithmic functions. Let's get started. Logarithmic functions are the inverse of exponential functions, and any exponential function can be expressed in logarithmic form. Similarly, all logarithmic function can be rewritten in exponential form. Logarithms are really useful in permitting us to work with very large numbers while manipulating numbers of a much more size. If x is equals to 2y were to be solved for y, so that it could be written in function form, a new word or symbol would need to be introduced. If x is equals to 2y, then y, which is the power on base 2, to equal x. The word logarithm, abbreviated log, is introduced to satisfy this need. Y equals the power on base 2, x. This equation is rewritten as this given one. And this is actually read as y equals the logarithm of x base 2, or y equals the logarithm base 2 of x. A logarithmic function is a function of this form, which is read as y equals the logarithm of x base b, or y equals the logarithm base b of x. In both forms, x is much greater than 0 and b is much greater than 0, and b is not equal to 1. There are no limitations as to y.
Examples. Rewrite each exponential equation into its equivalent logarithmic form. Number 1. 5 squared equals 25. Solution. 5 squared equals 25 becomes 2 equals the logarithm of 25 to the base 5. The base remains the same, which is 5. Number 2. 4 negative cube equals 1 over 64. Solution. 4 negative cube equals 1 over 4 becomes negative 3 equals the logarithm of 1 over 64 to the base 4. The base remains the same, which is 4. Number 3. 1/2 to the power of negative 4 equals 16. Solution. 1/2 to the power of negative 4 equals 16 becomes negative 4 equals the logarithm of 16 to the base 1/2. Number 4. 2 cubed equals 8. Solution. The given's base is 2, so we will put that beside logarithm as 2 on the left side. Then, we'll switch 3 and 8 to the opposite side of where they originally were. So, our final answer would be logarithm of 8 to the base 2 equals 3. Number 5. 2 to the power of 4 equals 16. You can tell by now that the logarithmic form of the given would be logarithm of 16 to the base 2 equals 4.
Rewriting logarithmic equation in its equivalent exponential form. Number 1. 2 equals logarithmic of 36 base 6 becomes 6 squared equals 36. Number 2. p equals logarithmic of m base a becomes a to the power of p equals m. Number 3. c equals logarithmic of b base a. Following the two examples from before, you can now tell that the given exponential form would be a to the power of c equals b. Number 4. 2 equals logarithmic of 9 base 3. Again, following the examples given before, you can tell that the new exponential form would be 3 squared equals 9. And lastly, number 5. 2 equals logarithmic of 16 base 4. Following the examples again from before, you can now tell that the given exponential form would be 4 squared equals 16.
So now, we will be proceeding to solving equations. Number 1. The logarithm of 49 to the base 7 equals y. Solution. The logarithm of 49 to the base 7 equals y becomes 7 to the power of y equals 49. Since 49 equals 7 squared, it becomes 7 to the power of y equals 7 squared. So, y equals 2. Number 2. The logarithm of 1 over 8 to the base 2 equals y. Solution: the logarithm of 1 over 8 to the base 2 equals y becomes 2 to the power of y equals 1 over 8. Since 1 over 8 equals 2 to the power of negative 3, it becomes 2 to the power of y equals 2 to the power of negative 3. So, y is equals to negative 3. Number 3. The logarithm of 8 to the base y equals 3. Solution: the logarithm of 8 to the base y equals 3 becomes y cubed equals 8. Since 8 equals 2 cubed, it becomes y cubed equals 2 cubed. So, y equals 2. Number 2. The logarithm of y to the base 4 equals negative 2. Solution: the logarithm of y to the base 4 equals negative 2 becomes 4 to the power of negative 2 equals y. Since 4 to the power of negative 2 equals 1 over 16, it becomes 1 over 16 equals y. Example number 5. The logarithm of negative 9 to the base 3 equals y. Solution: the logarithm of negative 9 to the base 3 equals y becomes 3 to the power of y equals negative 9. This is not possible since 3 to the power of y will always be a positive result. Recall that logarithms have only a positive domain. Therefore, negative 9 is not in the domain of a logarithm. The often used bases when working with logarithms is 10 and e. The letter e represents an irrational number. Its value is approximately 2.718281828. Logarithm base 10 or logarithm 10 is known as the common logarithm, while logarithm base e or logarithm e is known as the natural logarithm and is written as in.
So next, we'll be finding the logarithms of the following given. Number 1. Log base 10 of 100. Let x be equals to logarithm of 100 base 10. Then, 10 to the power of x equals to 100. Since 100 is equals to 10 squared, therefore 10 to the power of x is equals to 10 squared. So x is equals to 2. Therefore, 2 is equals to logarithm of 100 of base 10. Number 2. Log base 10 of 10,000. Let x be equals to logarithmic of 10,000 base 10. Then, 10 to the power of x equals 10,000. Since 10,000 is equals to 10 to the power of 4, therefore 10 to the power of x is equals to 10 to the power of 4. So x is equals to 4. Therefore, 4 equals logarithm of 10,000 base 10. Number 3. Log base 10 of 0.1. Let x be equals to logarithm of 0.1 to the base 10. Then 10 to the power of x is equals to 0.1. Since 0.1 is equals to 10 to the power of negative 1, so x is equals to negative 1. Therefore, negative 1 is equals to logarithm of 0.1 to the base of 10. Number 4. Log base e of e. P.S. The ln in there is a so-called natural log which is equals to logarithmic base e. Now, let x be equals to ln e. Then, x is equals to logarithmic base e of e, which implies e to the power of x is equals to e. Since e is equals to e to the power of 1, so x is equals to 1. Therefore, 1 is equals to ln e. Number 5. Logarithmic base e of e squared. Let x be equals to ln e. Then, x is equals to logarithmic base e of e squared, which implies e to the power of x is equals to e squared. So, x is equals to 2, therefore, 2 is equals to ln e squared.
So that concludes this video. Once again, we thank you for choosing this video as your means of learning. Have a good day and goodbye.